wearing glasses was fun. Right, welcome to the second Python lecture. I understand that some of you might not actually have been here in the first one, so don't worry. You can go over it. It's been recorded, so you can learn some things, but you don't need that knowledge at the moment, per se. So what is it we're going to create? We're going to do two things and see if we can do a third one as well. But the first two that we're going to do is we're going to create a script that has a random set of points. We can arrange the points however we want, and then create a Python node that basically joins up those points if they are within a specific range. Has anyone seen a space frame structure before? That's for sure. So you're in 6th year and no one's seen a space frame structure. This is not good. Come on, guys. I can expect that from our first years, but not from you guys. Space frame structure. Okay, we're going to Google it so you can see what it is. We're just going to do a quick Google of what a space frame structure is. The fact that you said that you didn't is actually quite depressing. Let's go to images. Did I type it correctly? I can't even see that.
Oh, wow. Yeah. First.
What did I say?
Yeah.
It's called a space frame structure.
I know this name. I know what that is, but I don't know.
Okay, so I should have just shown you guys a picture because apparently you don't even know the names of the structures that you're designing. Excellent. So far, yay. So what is it made of, right? If we think about it, there's points, which are acting as nodes for those of you who know graph theory. Maybe. Hopefully read some things. And then some edges, which are the connections between them, right? So what we're going to do is we're going to create a very complicated, as complicated as you want it to be, space frame structure. So instead of you guys having to model something like this, right, as a structure, so a very organic shape, what we're going to do is we're going to create a Python script that allows us to do the work automatically. The only thing that we have to put in is those points. Okay, everyone with me so far? Everyone understand what I'm saying? Guys, if you don't understand what I'm saying, let me know. I'll explain it, okay? I want you to follow as well. Right. So, number one, what's the first thing we might need if we are creating a space frame structure? Yes, we need to set up a series of points. That's all we need, right? A series of points, but not just on a plane, on a three-dimensional plane. Because, you know, this is three-dimensional, right? It's not just on one plane. It's got like levels and stuff, right? So let's do that. We're going to do it randomly. We don't really care at the moment. You guys are free to play around with these scripts after we're done. Blah, 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 blah. Going back to here. So what's the easiest way of creating a series of points? Populate 3D, yes, populate 3D. So for everyone who has never touched Rhino or Grasshopper, open your Rhino. Once you open Rhino, all you have to do is go to this command bar up here. Where are we? Where is it? Oh. Can you guys see my, there it is. There you go, and type in Grasshopper. Okay, that's all you have to do. And it'll open up this thing. So this is Grasshopper. So open Rhino, type in Grasshopper, press enter, and it'll open up that. Let me know if you guys are at that point. You're at that point? Yeah, you got it? Okay, so Grasshopper is basically what allows you to create anything parametric or visually code something within Rhino, as opposed to just drawing it up in lines manually, okay? So we're going to be playing around in there today, which is fun. And the first thing we're going to do is just if you double click within the empty space there, you get to tell it what nodes you want. What is this?
Had to eat.
Had to eat. What do you mean you had to eat? You were here last week. I've never heard of architecture students getting lost in a building. You guys are going to be designing this shit in a year. Fine. Right. So we just double click in there and just type populate 3D, or just if you say pop, it should pop up. I know you won't be able to see it, but it says populate 3D there. And press enter. Right. And if we zoom in there, if we just really zoom in there, we can see that it created a box, and it has a ton of little points in it. Can you see them? Yeah. Yeah, we can play around with the settings on this. You know, it's we can define our region, our count. So basically, how big of a box do we want to give it to have points in? How many points? Seed is basically just a random iteration of them. So, you know, random iteration 1, random iteration 2, whatever. It doesn't really make a difference. All we care about is that we have some points on a 3-dimensional plane that we get to play around with. Okay. If any of you want to create something in particular that is dynamic in nature and organic or whatever, you can put your own shape in there and just ask it to populate it with points and create something cool, or you can just create some points randomly around there, also fine. But it's easier if we just go with the same thing, because we're gonna be playing around with the units. Right. So the next thing we're gonna have to do, what else do we have to do? What else do we have to do, guys? Once we have the points, what do we do? No. We need the script. They're connected, right? Like, okay, we've got the points. Now we need to connect them. So, how do we create a Python script in Grasshopper? Yes, so we double click in there again and just type in GH Python. This down there, GH Python script, or just type in GH and then press enter. Hi, what did you say?
I should write it as Python.
I am not gonna make fun of you for that. Your fellow students can. mean people. Right.
We don't promote the.
Okay, so we're gonna connect this to here, and we're also going to. What else are we gonna do? What else do we need to do here? You guys at the back, you don't have to answer this, but they've been through a course already, so they should know. What else do we need to tell it here?
Whether it's a string or.
Yes, what is it? It's a variable. A variable could be anything. What kind of data is it? Come on. It's not an integer. It's not. It's a point. A point is a geometry. Okay, it's a 3-dimensional grasshopper. Point 3D. That is correct. Yes, you can put point 3D. And what else? So if we right-click here, what other options do we have? By the way, you have to do this, every one of you. So if we right-click here on the X, the X is our input into the script. Okay, it's just a reference for it. There's two things. There's something called item access, list access, and tree access. And then type hint is basically where you tell it what it is. What's the difference between item, list, and tree?
Item is one.
Go on. Yes, item is one object. Do we have one object? No. What do we have? A list of objects. Yes. Why isn't it a tree access? And why is it a list access? Yes. Yes. So a tree is basically when you have a list within a list. But in this case, we only have a list of points, right? So we're just going for list access. For the people in the back, again, don't worry about this. This is just them learning to code. And if we're going to type hint, I mean, it already says it's an object with geometry, whatever, but we can just tell that it's a point 3D. So that it knows that, okay, so what we have here is just a set of points. So if we go down, whoops, sorry, type hint, point 3D. Simple stuff. Right, okay, so we've created a set of points. We created a Grasshopper script to put it in. Now we just have to create the actual coding language that determines that, okay, so if I have a series of points, it needs to look around for all other points. If those points are within an X distance of each other, what do? We connect them. How do we connect them? With a line. Yes, we create a line. What do we tell the line? How do we draw a line in Grasshopper? How many points are on the line? 2. Start point, end point, right? So what I need to tell it is, okay, construct a line that has as a start point where one of the points, our point that we're looking everything else around, yeah? And then points at any other point that is within range, okay? That's all we're gonna do. Simple enough? Does everyone understand the logic?
Yeah.
Anyone not understand the logic? No? It's quite simple, right? You have a set of points. Each point is going to look around for all the other points. It's going to measure its distance from them. And if it's below a certain range, it's going to draw a line between that and between itself and the other point. Cool. Everyone's with me so far? So far, so good. Right. Give me a second. I need to check something. If this is going to work. Okay. Right. This is gonna go. So, oops, sorry. I think I pressed something. So let's go back here. Okay, guys, in order to make it easier on us, we're going to switch X. We're going to name it PTS, so points, okay? So the way we're going to do it is just, we're going to right click on it. And then where it says X on the top there, just if you click in it, you should be, whoop, sorry. Didn't work. Okay. Why is it doing this? No, it's, well, I'm hoping not to, but let's see. Right click, X, PTS. There we go. Okay, so all we have to do is just right click on that X and write PTS, just points, right? It's just for our reference because when we're going to be writing it within the script, we want to be able to represent that PTS as opposed to X. It just makes more sense to us common folk who don't speak machine language. Now, there's 2 things that we should also add. We need 2 variables. One would be the threshold. So at which point, distance-wise, do we connect the points together? So that would be our threshold, right? And then the second one is something that we need to add so that it doesn't look freaking weird, is maximum number of links. So each point is only going to be allowed to have X number of connections, regardless of whether or not it can connect to more. Because, you know, maybe you want to save up on materials and stuff. So we're just going to give you that option as well, okay? So the way we're going to do that is going to create 2 variables. So you know how we have PTS there? We're going to go down, and you see these little pluses that are there. You just can just press plus here. Right click and write. The first one would be threshold. And the second one, so let me just go like this. You can see it there. And then the second one right click on the Y or whatever it is on your screens and just write max link. Don't put any spaces between them. Very important. Will be exactly as I've written it down here. Okay. If you wanna, usually it starts, Python script starts with two options. All you have to do is press, if you zoom in far enough into your Python script here, you'll see the little pluses and minuses. If you press plus, it gives you another option. And just do that. What do you think we're gonna add in threshold and max link? A slider, yes. We're gonna add two sliders. Let's just go with a threshold of 2 units. So if we just double click here and press 2, we get one slider and connect it to the threshold. Whoops. The fact that I have to look on the left and draw like this is not very comfortable. And then just make max link, I don't know, let's say 6. No more than 6 links. Okay. Terry, you're right. You want some help? I can come back. You just stop by. Yeah. This. So super simple so far. Right. So what do we need to do before we go into the scripts? What's that 2 and that 6 that we've added? What are they? Inputs, but what are they? What kind of data are they? Integers, yes. So how do we set these things as integers? Right click. It is indeed an item because it's only one. And we go here and in the type hint and add int. Int just means integer, so it's just a number, okay? So in the type hint for both threshold and max links, we need to change it into an integer. So type hint, int. Okay. Everyone done that so far? Yeah? Yes. You have a problem? I'll come around. Okay. Yeah. Right. Okay. Don't worry. At the end of this, I'm going to share with you a ton of scripts that you can go through with Python to create some interesting shapes. But first, we have to go through a couple together in order to, well, just have a bit of fun, right? So we're now ready to open this thing up. Just double click it, and you should get this window. Double click the Grasshopper Python script, and you should get this window. Everyone have it? Right. Okay. So this is where it gets a little bit complicated. We're going to need a few things. The first thing we're going to need is Rhino geometry, right? Because we're going to be talking about creating lines and all that kind of stuff. Now, in order to do that in Grasshopper, we have to import Rhino geometries. So all you have to do is just type in import. Whoops, I misspelled it. Imports. Yeah, there you go. Should light up. And it luckily has this thing that drops down here to help you out. So the only thing you're going to do is write Rhino dot geometry. Did I spell it correctly? And Rhino dot geometry as So instead of referencing it as Rhino geometry this time, we're just gonna reference it as let's see, RG. Because every time we want to open up the Rhino geometry, instead of saying rhino.geometry.line, for example, we just say rg.line within the script. Yes. Yes. Sorry. I'll make this even bigger so you guys can see it, because we're going to be typing a lot of things. Okay, so can you guys see it now? Yeah, at the back. Import Rhino geometry as RG. So the only thing that we're doing here is basically allowing our Grasshopper script here, our Python Grasshopper script, to use Rhino geometries, which is, if you go into Rhino, it's the points, the lines, the rectangles, everything that you can draw on Rhino. You're going to do the same thing here. You just say rg.line, and it will tell you, okay, so I need a start point and end point, and then you just reference that in, and it'll draw a line. Okay, simple stuff. There's another thing that we need to do, and import CLR. So this is a bit weird for you guys, but and this might be a little bit advanced for everyone. It's okay. Just write what I write, and I'll explain what I've done first. Okay. CLR dot add reference open brackets. Okay, so can anyone explain to me what I've done? What are very important things that I'm, yes, for sure.
We have data tree that is population 3D, like that 3D set of points. We are referencing it in Python so that we can understand it and survey that.
It's a list. It's not a data tree at the moment. So actually, what happens if we have? Well, we're gonna search for a list of things within a list of things. We're going to create a list of things within a list of things. We're going to create data trees, right? So when it's going through each iteration trying to find other points, it's going to use data trees. And in order for us to use those data trees, we have to sort of enable them within our script. So this CLR with that reference Grasshopper is so that I don't have to copy that thing over again. It says from grasshopper.kernel.data import GH paths. GH paths is what's going to allow us to create those modules, those lines. And then Grasshopper import data tree is so it allows us to have lists within lists. Don't worry too much about it. The important thing is there's more complicated explanations for it, but the important thing is we're going to need to do some stuff that relies on some modules that are not currently within our Python script. So I've just put them in there, okay? You guys don't have to worry about this. It's just so that things work. Now, we're going to create a class called module1. How do we create a class? Yes, so we just have to type in class, or naming it, and module 1. So a class is basically a blueprint for creating something, okay? In this case, is a module. So I'm going to create the blueprint for creating a module so that every time I want a module to be created, all I have to do is add another instance of that class. So if you think about it as humans being genotypes, right? So a human is like, it has eyes, it has eye colors, it has ears, it has legs, hands, it has skin color, right? We don't care what that skin color is. We don't care what that eye color is. We just care that it exists. So when you're creating the blueprint, all you care about is defining all the features that exist. An instance of a class, which is an object, is when we take that class and create an instance of it. So a real sort of version of it, which will have, if we're talking about humans again, it will have eye color. So I have to specify eye color, right? So is it blue? Is it green? But when creating a class, all you have to do is just define what are the attributes, what are the features that are going to be in there. 2 features, mainly. So you need this colon for people who, I'm assuming you can see in the back. Let me see if I can zoom in even more. There we go, module. So you need this colon after module 1, and you just, we're going to create a definition. Self, comma, PT. So I've created something called def space init, like 2 underscores init, 2 underscores open brackets self, comma, PT. This is in every class that you create in Python, you're required to write this and the self part. The PT is just one of the variables that we're going to have. We need the point basically to create this module, and that's going to be different every time we create an instance. So this is just to initiate that. So when we want to create an instance of the class, we just have to initiate it. So we need this as part of the blueprint in order to initiate it. Okay, it's just what the syntax is. Don't worry about why it's called init. It's just the person who decided to create Python said that this is the way that we're going to initiate all instances of objects within classes. We just have to have something called def init. Okay, yeah, no. It's initiate. I guess he just wrote init, and then he figured out that if I have like def space underscore underscore init underscore underscore. I mean, if you went back in time and you asked him maybe remove the underscores, it might have been easier. But yeah, the guy decided to do it that way, so that's just how it is. The self is just basically to initiate itself as an instance, and the PT. What's PT? Yeah, but what is it in this instance? A variable, yes. So it's just one variable, something that when you initiate the class, you have to give it a variable. In this case, it's our point that's everything's gonna center around, right? So for every point, it's gonna check who is near it and create links. That's what it's gonna do here. But in order to do that, it needs to know which point is it checking from, right? So that's what I'm doing there. I'm just adding that part. And same, the guy that designed Python decided for us to write self.pt equals PT. And yeah, as a way of doing it. But I'm going to add something else as well. I'm going to add self.links equals to a list. So what am I doing here? Yes, so what I'm doing in here is every time you create a module, right? It'll start from a point, any random point, and it will create a list of all the links that it can have with other points. Okay, it's an empty list now, so this square brackets means that it's a list. And every time you initiate it, we're gonna tell it what to put within that list. Okay, everyone with me so far? This might be a little bit advanced, guys. But bear with me, it's gonna look cool, and then you mess with some numbers and it looks even cooler, and then you change the location of the points, and then you do whatever you want. But you have to bear with me on this one. I know it might get a little boring. So, okay, there's a couple of other things that we need to do as well. Indentation is quite important. So when you press enter and you write something else here, make sure that it's in the same line as that def, okay? Not in a different line. These ones, the self-PT and self-links needs to be a tab sort of further in, but what we're going to type here should be at the same line as def. So we're going to create another definition that's called connect, right? Because, yeah, well, we need to connect all those points together, right? So we're going to create a definition that does that. And we need two parameters here. I want it to connect itself. So, you know, whatever this point is within itself to other modules, right? It's just connecting itself to other points. That's all we need to do. Yeah. So you know how we have a distance as a threshold, okay? And we also have a max length. I can't just connect everything regardless of distance. I need a way to distinguish how it prioritizes things if we have a maximum amount of links. So what would be a good way to prioritize which points it can connect to? Let's say I have 10 points that are eligible to connect to my point. How would I go about in distinguishing which ones? Yes, Mary? Which one's closer? Yes. So I need to sort the list, right? So I need to somehow sort this list out that when it finds out which ones are eligible, it sorts the list based on distance, and then it picks X amount being the number that we set as max links, and connects to just those ones from the top, okay? Everyone with me so far? I mean, Mary's first year, never even heard of Python, and she's just like getting it, right? So you guys have no excuses in the 6 years. Yes, I'm trash talking you. It's fine. Right. So, yeah. So let's do that. So we need to type in sorted modules, comma key is equal to lambda m dot pt dot distance to self dot pt. And let's see if that works. Sorry, let me just increase the size of this so you can all see everything. Okay, so lambda m colon m dot pt distance to software. Okay. Okay, so what have I done here? You've never seen this before. You have? Yeah. What is it?
That thing.
It's a for loop.
Oh.
It's basically just a for loop, more or less. Okay. So what I'm trying to do is sort the modules. So if you cycle through the modules, this is M for the modules. You cycle through the list of modules, right? Sort them based on the distance to the point. Instead of doing for every point within the list and all that kind of stuff, this is just a shortened way of writing it. Okay, you're all stuck on that. You know how we say for m in modules, right? For every module within the modules list, right? Sort the list, or actually find the distance to, and then sort the list, whatever. I'm just doing it in one line.
What's key?
Key equals lambda is basically a variable in this. So that's the key by which you're sorting out the list, which is the distance to. Okay, don't worry too much about it. It's just a for loop, more or less. It's just a shortened version. That's
How would you write
it? Sometimes you have to show off and explain that there are other ways of writing it. So when you come up with, when you see someone writing this, at least you know what it is. Okay, so, I have to expose you. Exposure is part of this. Right, so we've done that, and we're also going to write it for M in modules. If lengths no, it's not self and M not in self links. Distance. Self.pt actually. So, complicated, I know. Let's break it down again. What do I want when I'm cycling through? Why do we need to sort the list first? How do you go through a loop? How does a computer cycle through a loop? One item at a time, starting with the first item. So item 0, 1, 2, 3, 4, right? If we want the computer to only take the ones that are closest in order to be more efficient, right? Then we first need to sort that list so that only it starts from the closest points and then goes down. Then, just because we're sorting it to the closest point doesn't mean that every single point is eligible, right? So we have to loop through it and create the links. And we're starting with the first one, right? And then for every single one of them, first, we define at which point do we stop cycling through when we reach the maximum amount of links that we want. Then we say, okay, let's say we haven't reached that yet. We're defining which points are eligible to go within the list. And those points are if the distance is less than the threshold and we haven't reached the maximum amount yet. So it's going through this, it's going through this, it's going through this, it reaches the maximum, it breaks. Or it's going through this, it's going through this, it's going through this, but it doesn't write it in because even though we have we have more room within the list before we reach max link, which is the variable. It doesn't matter because those points are not eligible, so it doesn't pass through here, right? But it still cycle through them until it says that it'll still cycle through them anyway, and it just won't be added because it's not eligible. Does that make sense? It's a little bit complicated. It's a bit of lots of code, but in the end, all it's doing is selecting which ones are the closest points that are eligible, and then connecting to them, making sure that you don't over exceed the number of connections that you want. Yes. What's the input within the script?
Oh, right. Oh,
Max link is the input. So if you type in 6 within that slider, that means that you can only get 6 items, 6 points that are the closest in order to connect to it.
this will only have 6.
the list will always have a maximum of 6. It can have less than 6. You might have a point that's so isolated that given the threshold, no other points can connect to it, right? At which point there's no connections being made. But there is an option to go up to 6 within that list. Everyone okay with that? Okay, we have one more definition to write. And so this one created a list for us of all the possible things, all the possible points that we can connect to. What would be the logical next thing to do? Connect the points, yes. So we need to actually create a definition to connect the points. Okay, we found out which points are eligible. We've done all these things. Now we just have to connect them. So remember, it needs to be in the same line here because we're going to run another definition. So def should be in the same line. It might be easier. So you have a question? All right. Anyway, all right. Let's just what do we name this? Generate. Let's just generate it. By the way, the names of this mean nothing. You can name it whatever you want, except for the init. That's set by the guy who created Python. So any complaints, write to him. Right. So we're gonna. Oops. What did I? Right. Define generate self. ID is equal to center dot branch count. Okay, so anyone familiar with data trees in Grasshopper? Yeah. Okay, so I'm going to explain it. It's a tree. What do trees have? Branches, right? So if we're thinking about a tree and we want to access something like a leaf, we have to go through the whole tree, through that branch, with as many branches, and then identify the tree within that branch, right? So it's a list within a list within a list, whatever. So that's the tree structure. What I'm creating here is because I'm going to have the list within list and so on and so forth. I'm just creating ID as being the center point of branch count. It's just don't worry about it. Okay, it's just basically a variable that's identifying that particular branch count. And now we're going to define what center actually is. Well, actually, we'll do center.add. So that center will be all the center points that are going to be connecting. Okay. And we'll define it by, let's go back to our script before we write that. You know how we have out, a, so on and so forth? We're going to add a couple of things. The first one, we're going to define center here. So we just have to write what we wrote in there, center. And then we're going to add another one down here. That's going to be called our ARM3 PTS. We can name it whatever we want. I'm just, there's a reason. We'll go through it why it's called ARM3 PTS, but it could be anything. It could be output, it could be, whatever you want to call it, but we're just going to name it that for now. So if you go to your scripts, your Python scripts, and you go to the right of them, as opposed to the left where you wrote threshold max links, and you add center and ARM and 3 PTS, that's basically the outputs here. And I'm defining what it is here, and well, basically here. Okay, everyone with me? Yeah? This is going to be very complicated, and it might not work for everyone. So, because you might have missed something. So at the end of this experiment, what I'll do is share the actual code in order to everyone has a sort of a point by which to start. In the meantime, though, let's continue writing. Yes. The list. What are you talking about? Are you talking about up here?
Yeah.
So I'm sorting the list already.
Is there a way to see it maybe connected to the panel and see the list?
Being sorted.
Yeah. I don't know, just to see from this happen.
We could print, but
Print the list and make an output.
yeah, you could do that if you wanted to. So you could say modules or print modules, and then after you sort the list, you print modules underneath it as well, and then see the difference between the two lists. If you really wanted to, I mean, you don't have to, but if you want to see sorting for whatever reason, sure, why not? Okay, so you know, I don't judge. Whatever everyone wants to do. Self.pt, so we want the point, and we need the GH path ID. So, oh shit, what was I writing? I wasn't typing. What was I writing it? Sorry, I didn't click on it. And I can't see the screen. I'm sticking there. So it's add self dot comma gh underscore path. What am I typing in? GH underscore path. Oh, there we go. Thank God. Which one? Self.pt, comma gh path ID. So what I'm doing is just adding one piece of data within the branch. Okay, this is getting a little bit complicated. We need a whole lecture series on how to traverse branches and tree data structures within Grasshopper. But for now, this will work, trust me. Okay, it's just link. Whoops, that's num. Yeah, link num. Links. So what did I create here? Yeah, is equal to what?
The length of the list of the cells.
Yes, so the link number is equal to, I just created a variable called link number that is equal to the length of our of the number of links that we have, so that we can count how many we're going through, right? So it's a way of knowing what our max is, so that now I can say for I in range, and open brackets, what do we call it? Link num. So for I in range of link num, so because we know here that link num is the length of the list, that means that that's how many loops we have to go through, because we have to go through every single one of the items within the list, right? So for I in range of link num, it basically just goes for every item within within whatever however long this list is. So if it's 10, then it'll go for every item in 10. So it'll go 10 loops, right? We're going to create another variable called pt2, which is equal to self dot pt plus self dot links I t close brackets divided by 2. So what have I done here?
That is the second.
Yes. What is that point exactly?
It's the addition. It's the half. It's
It's the half, it's the midpoint, yes. Good job. So it's basically saying the second point is equal to self.pt. So every point in Rhino, right? Every point in Rhino is made up of an X, Y, and Z. So if you add points together, so if you add, let's say, 1 point plus another point, right? You're adding a vector in essence. We're adding self.links I, it means that it's just the index. So for I, if it's the second item on the list, it's just that's the index on the self-links list divided by 2. Okay, so it's adding the 2 points divided by 2. What does it get? The midpoint. Okay, so all we care about is finding that midpoint. So we created PT2 is the midpoint between our 2 points. Yep, and then we're going to create another loop. Sorry? Yeah, didn't. And then, for J in range, this one.
It's link number there. Link.
Oh, sorry. Yeah, link. Did I write N? Yeah, that's absolutely correct, because otherwise there would have been an error in the script. PT3 is equal to self.pt plus self links J dot pt on by 2. Then one yes, but not range in brackets. Whoops. Comma. Yep. Comma. H underscore. Okay, this is a bit boring. Okay, I know it starts to get a little bit boring because it's a lot of code, but we're gonna get to play with it very soon. So suffer through it for now. So I need to create an arm. If you think about your arm, right, it has 3 points. So that's what I'm creating. Okay, so in order to find the 3 points, I've I want the first point here, then the next point that's going to link, right? And then I want the next item on the list, so it's I plus 1, which is the next point here, and creating a range out of all 3 of them. Well, they're midpoints actually. So what I've effectively done is I added 2 arms, so 2 of these, and a center point. It's just a way of creating the connections. Loops through. Right. Okay.
Wait, why did you divide your point 3 by 2?
because I need the midpoint for it. So I need two midpoints and a center point, which is here. So, and then I'm defining it as a list of the points, and then their ID, which is their the branch count there. Okay, because we're gonna have list within list. So we've done the blueprint, let's say. So we've written down everything that we need to write down in order to come up with, you know, the creation of these modules. So one module will consist of what? 2 arms and a point, okay? Every module will have 2 arms and a point. Does that make sense for everyone? Okay, we're gonna move on. We're gonna initialize it. And the way we're gonna do that is first we have to define, oops, data tree. Oh. And then center. So it's the American and English spelling fighting each other in my brain. Oops, sorry. Which one's the English one? This is the American one?
Yeah.
So
We like
On your scripts, feel free to change the spelling. You just have to be consistent in it and change it in every part that it's referenced within the script, as well as the output up there. As long as all those 3 things match, we're good to go. It doesn't matter if you call it center, you call it whatever you want, right? You can call it, I don't know, Bob, you know, just whatever you want, name it. The script, computer doesn't know, right? Words are meaningless to it. It's just reference points for specific values. So, you know, you want to call it Bob's, call it Bob. You want to spell it differently. You want to spell center as, I don't know, S with an S. Yeah, like, I don't know, some kind of anti-establishment rebel, you know, whatever. I don't care. You know, if anyone hates English, go for it. Butcher the language. The machine doesn't care. Right. So, rg dot point 3d. No, actually, it's point 3d is with a small one. Okay. And then the other thing to initialize the output prints is arm 3, no, 3 PTS. Yes, correct. It's equal to data tree RG dot point 3D. Whoops. Oh, and actually, no, it's not point 3D, it's point 3D. What am I doing? Huh. Right, so here, the only thing I'm doing is initializing the results, okay? So the only thing I'm doing is because I have distance within here, I'm just initializing the results. There are going to be data trees that feature lists of points, okay? Remember, this is a list of well, it's going to have a list within a list, right? So I'm just creating that, initializing it. That's what's going to be. Remember when we were coding, and if we wanted to manipulate a list as an output, we had to set A as equal to an empty list. That's how Python works. It's the same thing here. I'm just telling it, instead of being an empty list, it's just going to be a data tree with points. Okay, it's going to be a data tree with points. That's all I'm doing. Just initializing that as an output. And then obviously, we need to also create modules as a list in which we're going to add those points in. So this is where we're going to create all the thing that we created, the whole class. This is how it's going to run. Okay, all it needs to do is for every point in PTS, so for every point that's coming in our script here, that's called PTS, right? Remember, all our points are called PTS, right? So for every point in PTS, which is for every, it should be an in here, sorry, I forgot to spell that. For point in PTS, so for every single one of those points, what do we need to do? Create a class. M is equal to module 1 and the parameter, which if we go up, you'll see the parameter that we've set for the thing is just a point, right? So there you go. M equals module 1 for the point. So yeah, for every point, that point is created as an instance of the object and appended within the list. So M appends M, which is the new class that we're doing within the list of modules. So what I've done is for every single one of our points, I made it into an instance of the class modules and made and placed it within the list of modules. Okay, so far so good. Then this is we're getting to the end, guys. This is it. For every module within the list of modules, right? We need to connect the modules, right? So we're running the definition connect, if you remember, with the parameter modules, which is the list. So if we go up to the definition requires the list modules and the fact that it's connect. So I'm just running that for every single one of the items within the list, just finding its connections. And guess what else I need to do? What other definition do we have? Generate, yes. So for M in modules, so for every single one of those, after you find its connections, M dot generate. All right, let's moment of truth here. Yeah, it works fine. I mean, I wrote it okay. I don't know about you guys. So, syntax error, you guys missed some stuff then. Yeah, so hang on. Which line? 26 here. Okay, this is where the fun begins. So I'm just gonna do a Control A, Control C. Does everyone have access to ADD Teams area? Yeah, the ADD Teams area. Everyone should have access to it. So if you go in Teams, maybe, I don't know. So I'm just trying to find a very easy way to share this script with you guys. Okay, let's just try that one. So let me see if I can send it over in here in the chat. All right, so I put it in the chat there, so hopefully you guys can access it as well. Has anyone's worked? Yeah, here you've got it. Does it play? It doesn't show a lot. It's not about showing a lot. It's just there's no errors. No errors. Okay. All right. So. Where is it?
Oh, I know it.
Okay, so this is where we get to have we need to interpret this output a little bit, okay? And okay, so where would be a good place to send the scripts? Yeah, we can do that, sure. What would be the easiest way to share a file?
You know the chat that was it the student hub?
It should be the ADD. Oh shit, you might not be even invited. No, you are. Everyone should be there.
Yeah, you can't.
It's the ADD one. Okay, so Miro boards group. Is there any place that we can have a group to share these things? Try we transfer it. Is that easier? Can we transfer the whole script? Yeah, let's do that. Let's just we transfer. Hang on. No, I'm just gonna we transfer it and then put a link, and then you guys can just download it through that link. Okay, give me 1 second. Yours worked. We're almost there. There's one more step in order to make it look like an actual modular thing. And give me a second. I'll show you. Let me just send the script to everyone so that everyone has it. Because you know, it's not fun if you're just following along. Python workshop. We get transfer link. And okay, let me just put it there. Guys, can you see the link here? There you go. Can you just type that link in and see if you can download it? It's 2 scripts. It's the 2 things we're gonna do.
I won't be able to transfer. I have an idea of
You have an idea, but not really.
They don't be able to recreate the entire syntax.
That's fine. That's fine.
Is it supposed to make anything?
At the moment, no. There's a reason why. Okay. Yes, we're gonna play with the outputs a little bit because what we need to do is create NURBs. So NURBs is it's going to you know how a NURB is as opposed to a mesh, right? So we're gonna create a NURB in order to understand that geometry. Right. Is everyone able to download this? Can you? Yes, you just have to open it in Grasshopper. So when you go to Grasshopper, just need file open and open that file. No, this is a WeTransfer link. Oh, yes, you need to type that in. That's generally the idea. Yes, Meg. Yeah. Patience. There's a reason why. Don't have any green things. That's all. Have you pressed on it? On the Grasshopper script? Come on.
Oh, when you put that out, I've got the same issue.
Okay.
Yeah.
Okay, so All right, has everyone downloaded it if they're not able to do it by themselves in terms of, you know what, just you guys are killing me. Right, let's go back to the script then. So everyone is at this point, and some of you have some extra things. What are those extra things that we're adding? Well, quite simply put, give me a second. So we need to create NURBS. Oh, you can't even see it there, can you? Can you even see it there? Not NURBS curve. Well, no. Well, I can't do it in there. Let me just see it here. One sec, guys. Let me find the correct one. Okay, so sorry about that. Just about me finding the correct one where it's closer to me. So if you type in, whoops, if you type in NURBS curve, this one here, can you see it? And we connect our arm points to our vertices. And we also change the degree. Well, let's go with 1 to begin with. Actually, let's make it into a panel. And name it into 1. Nope, that's the wrong connection. Relax. Okay, so what I did is create a NURBS curve. NURBS curve is what's the module called, and then created a panel and just wrote 1 in. But you can just so how do I create a panel? Let me just show it to you guys again. If you double click and write panel, you'll get this, well, what's called a panel. You can write whatever you want in it. If you double click in it, in this case, I just wrote 1. I'm just going to create another one that says 2, right? So there's 1 and there's 2. I'm just going to make them a little bit smaller because they don't need to be that big. Okay. Then if we click here, so by the way, the reason why you can only see this on mine, for those of you who've never used Grasshopper before, if you go up here on the top right, you'll see some cylinders. Instead of just having pressed the red one, I've pressed the what's that color? Green, the half green one. Yeah, that just means that it will only display the one node that I'm touching. Okay, so that otherwise, let me just unpress it and you'll see the difference. Otherwise, you'll see all the populate 3D stuff that I don't really care about. Okay, so I just want to see that for now. Mary, you all right? I'll come over. Yeah. Yeah. So any node that you press. It's kind of cool. So if you go and change the highest number of bits, for example, and then you change like the measures as well. Right, so that's with degree one. Degree one basically just means that it's going to be a straight line. If you press into degree two, what happens? I don't know. It's the first time I've seen it. I'm done.
No, once it, once it, I did not like. Reason, but I don't know why. Interesting stuff. Where is it? I think that's kind of you have the script description. Okay, so what happens when you change the degree to 2? No curve.
It will make a curve, right? Look how cool that is.
Right.
Yes. Would I do what? Zoom out of this. Oh, sorry. Yeah, so it's populate 3D. It's the script, the 2 parameters. Let me just tidy it up a little bit. And then I'm connecting it to the NURBS curve. So this is one way of going about it, and we're not done yet. So what we have here is just some lines, but we need to create a mesh. There's something that we can 3D print or add to a building that has some kind of solid form, right? So right now it's just a line. Yes. Yes. Why does the code break when you go up to 3 degrees? It's the way that calculates the NURB. You only have 2 points. Right. Okay. So it doesn't matter anyway. Right. Okay. So how do we create mass to this? Pipe. Yes. Let's just make a pipe. So all we have to do is just make a pipe. Just type in pipe. We're going to do something cool with it as well. There's a couple of ways we can do it. We're going to flatten this because we don't care. So in yeah.
Why does it do that?
Because the radius is.
Not necessarily. It's also the fact that I have a series of grafted, right? So it's list within lists.
So if we right click here and flatten it, where's flatten? That one? I can't see very well from here. And if you're right, the radius needs to change as well to, let's say, 0.1. Make it really small. There we go. Look at that. That's kind of cool, right? But what do we have now? Well, we effectively have a ton of little meshes. So if we go to the end here,
It'll give us like a ton of crap that it has coming out.
we don't care about a ton of crap. We just want to join everything. So we're going to flatten this part as well. This is flatten, right? We're going to flatten this part as well. And we're going to do what's called a mesh. And then mesh join. Right, so actually not this one, but go.
Mesh prep, do mesh prep.
And add this one here, and then we'll add this one here. And in the end, what we have is just one mesh.
So this is one surface. Okay, so I'm sorry, this one went a little bit fast. So what have we done? We've created a pipe node. So if you write pipe, give it a small radius, and then everything that comes out of it, I made it into a mesh breadth, and then joined all the meshes together. So now it's one form. So if you go to Scott at B15 or Jason, when we have the 3D printers working there, you can, that is 3D printable. If you give it to Jason, he'll take it for you. But you know, the idea is that works. Okay, so that is 3D printable now.
And yes, if you want to get that as an instance in Rhino and play around with it, all you have to do is just right click on mesh and click bake. I can't see. Is that bake? That's bake. It should be the first one, right? Okay, no, whatever. And there we go. I'm just gonna, oh, I can't do it here. Gumball is off on. There we go. Can I zoom out Grasshopper? Yeah, of course.
I'll come around. I'll come around.
Okay, so guys, a couple more things. The first one, right? So the first one is we created this pipe, but Grasshopper, thanks to Rhino 7 and the people at McNeil or whoever designs Grasshopper, decided to add some components that are called, I think it's called SAP 6, something like that. So
Multi-pipe. We need multi-pipe.
Okay, so go and find multi-pipe. Oh, electrocuted every time. So there's something called multi-pipe. Okay, so this is actually an interesting new component that they've added. Right? Now, in order to make it work, we need to interpolate the things that we've created. Yeah. Yours doesn't have it. Is it because you have Rhino 6? It's not updated yet. Yeah, so it's been a new update around about May or April last year, I think, something like that. Yeah. I was just stretching. Okay. Yeah, so okay, some of you might not actually be able to do this. Tough luck, shit happens. It's okay. It's just something kind of really cool that you're not able going, you're not going to be able to do anything about. It's the same thing, right? We interpolate here, we get some curves, we just flatten. This is flatten, right? This was this.
Yeah.
Okay. We join this to our curves up here, and then it looks kind of weird because we need to set a couple of things. The first one is the node size. So no point, not 1 for now. And then our 0.3 for our strut size. Strut size and 0.2 for our segments. And then wait, why isn't this working?
Yeah, that's the one. It's time to see everything.
You're going to Aikido? I'd like it to be noted again, Rudy is leaving for Aikido. So what have I created? Well, this allows us to create something kind of cooler. It's not very visible because these are very small numbers. But give me a second. Let's increase the size of the node. So let's go 0.1 as opposed to 0. For the strut size. There we go. Oh, sorry. That's wrong. Oh, 0.5. That one. Let's try saying the node size would be. Yeah. Okay, it should work now. There we go. Oh, it's a bit big. Okay, let's dial it down a little bit. There you go. Look at that. It's kind of cool.
Yeah. Yeah. Oh, mine. Zoom out and Grasshopper.
Yeah, sure. Sorry. So we just have to connect the interpolate here. Same as before, we just add a degree of 1 this time. Degree of 2 will not work on this one.
because it needs a straight line in order to create this pipe. So multi-pipe, what it does is instead of having a straight pipe where the nodes are, it has reinforcements and then it stretches itself out and so on and so forth. So it's kind of like a cooler pipe structure. Right, so this is one other way of doing it. So we have this one, we have this one, and there's one more. Which one's the easiest one? So there's one more way in which we can create a 3D object from, let's say, a surface. How do we create a 3D object from a surface? Extrude, yes. So we can extrude. No matter what we've created, we can just extrude it. So where is the NURBS? Down here. See this part here? We're gonna play around with it a little bit, and we're just gonna, yeah, extrude. First on the, let's do the Z-axis first for about 0.4. There. And that would be, whoops. This would be here. So we're creating this, but we can also extrude on the x-axis by the same amount. This is by far the simplest way of doing it, as opposed to pipes and so on and so forth. We're going to connect this one with this one. Trying. There you go. The three-dimensional object as well. So all I did was, I'm just going to zoom in a little bit here so you guys can see it a little bit better. I did an extrude on the z-axis, so upwards first by 0.4, and then again another extrude on the x-axis from the result in order to create a three-dimensional object that I can just mesh join again and just create whatever. Right, so we've got three options for you guys to choose from. We've got, and we're going to drag them along here, here, and here. Right, so 1, 2, and 3. And we can play with the options as much as we want and create as many cool things as we want. We can change the inputs of the points. We can change the thresholds. We can do whatever we want in order to create interesting shapes. So, everyone with me so far? Let me see. Don't work.
No more clothes.
It's just the size. Just the size. Yes.
Last one you did.
On the screen with extrude. Come on, it's the easiest. Look, this is my NURBS. I've connected it to an extrude node that's extruding by 0.4 on the z-axis, and then I connect that to another extrude node that's also going by 0.4, but on the x-axis. There you go. So you can play around with it. I'm going to let you guys play around with it for the next 10 minutes. Show me what you can do. Show me how creative you are by creating any shape using this script. You want to flatten the points and make a flat kind of facade, do it. You want to increase the size of the points. You want to make a shape, a donut, and populate that shape. So let me just explain something to the people who've never used Grasshopper before. You know how we have populate 3D here? You know how there's a region? we can change that region into anything. So we can create a 3D object, a cylinder. Type in BREP here. Select it. I'm going to change into shaded here. See that it's a BREP shape. Change that into that region. Right, it's randomly populating within that, and the results are in there. Okay, let's go back to wireframe because we can't see anything in there. Yeah. Right, so I populated that particular object and created an interesting shape out of it. Contained within that. Right, does everyone just play around with it? Just play around with it. Create something. Zoom out where? For the extrude, yeah, sure. There it is. Play around. Create something. Yeah, it's too big. I think this is right for the most of this problem. Otherwise, we do not want something. There must be. Nice. Well, this population needs to be completely outside of the pyramid. I was just defining for us. Yeah. Yeah. Look at that. So guys, instead of populate 3D, if you use populate geometry is much better. It works. So yeah, play around with it. I want to see some interesting designs. Is that everything is white, things are not. No, as in like okay, so in order to minimize the amount of time it takes to generate things, there's a couple of things you can do. Reduce the number of connections because that's probably the how much power it has, or deactivate parts of the script and then activate them afterwards. That was kind of funky, but it does from the outside, right? So what if you create a false model? If you create a Boolean difference, then another box is from inside, make a Boolean difference, and then do that to the left of just the outside. Right. Boolean difference if you want to cut shapes out of your shape. Yeah, see, that looks kind of cool. So that's definitely number one. Right? Is that how it is? Well, I didn't say no, but you may not want the bottom part.
Yeah, that's what I want to do the top part, not the bottom. Some reason the capital.
Because there is no straight two-dimensional shape you can cut with. It's a three-dimensional shape that you can cut. You may need to make your own cut. Donuts. Yes. So yeah. What does it say? Error everywhere. Well, it's because I think the threshold is too low. If we increase the threshold, There we go. Now we can find some internet. Distances are much greater. than what is previous. So you need to increase the threshold. Just add a large number of what the slider implies.
No.
You can. So you create whatever shape you want in random. So let's say, you know, whatever shape you want. That'd be cool. Right, so, it's not a surface of right. Double click is here. That would be on. And select that one. Select it, and right click there, set one breath. Okay, so now that is, I'm going to put that in geometry. Just geometry. Yep, and then connect that key into our ETS. Yeah, it's because the threshold is too low. I'm gonna have to increase the size of the threshold. And then start getting some connector. You're gonna have to create more like okay, let's go to the end. See what come up. Yeah. Cool. Yeah.
Yeah.
Cool stuff, right? You can do whatever you want. It's like painting a slider. How long would it take you to draw that? Yes. Yeah, so it's fine. That's fine. It's because the threshold is too low. Points are too far apart. Okay, that looks pretty cool. Right, so what did you learn? What did you learn from this exercise? What did you learn, guys? Come on, what did you learn from this exercise? We created something, and now you're all creating about 50 different versions of it. What does that tell you? Learn Python. Yes, learn Python. But actually, more importantly, is the fact that you can play around with a design. If you create a framework by which to generate something, and this is very important to my 6th years, who are going to be generating urban layouts and populating them with a ton of typologies. If you create the framework, you can generate as many iterations as you want by just clicking a button, by just changing a little thing. It allows you to go through thousands of iterations, whereas if you were drawing something like this manually, it'll take you a day to draw one iteration at best, right? So this is the power of generative design. This is the power of learning to code, to creating and using Python and Grasshopper in order to be able to reach the level of just adapting any kind of shape you want to your design. Right, there's one more algorithm that I wanted to go through, but it seems that we don't have that much time. So instead, I'm going to show you something that's going to be really cool for everyone. And I hope you're okay with it. So if we go into Google, everyone just Google this. ATLV Grasshopper. Python. ATLV Grasshopper Python. So these beautiful people at ATLV Educational Resources, never met them,
but they've been kind enough to well, create a series of Grasshopper scripts that feature Python in the creation of form. Every single one of them, different things. Goes from simple to complex and so on and so forth. Look at these shapes. So, what have you learned today? What have you learned today? You can take every single one of these and adapt them to your own design.
I told this last week.
Why would I help you guys without letting you struggle first? And also, I've noticed that not all my 6 years are here. So this is an incentive to show up. You want me to stop very Right, okay, so yes, you can adapt any single one of these. You can create your own if you feel comfortable enough. You can change these into other things by just changing some of their numbers, but in keeping with the same logic, right? It's very simple, guys. You can cheat your way into a cool design. You don't have to, but yeah, yeah, it's fun. Does anyone have any questions? No, you're all kind of taken apart. You're gonna like in awe of the power and the possibilities unlocked here today. Yes, yes. Right, that's it then. That's it for today. Play around with as many scripts as you want. Yes. Yes, okay, so if you ever have any questions about Python coding, about adapting any of these scripts, about anything, there's something called ADD drop-ins. ADD drop-ins is running every day, and the good people at ADD drop-ins, which I used to be one of them, and I will be again in the second semester, because that's when I'm going to be helping you guys. Because, well, let's just say coding CA models and agent-based models within Grasshopper is a little bit more unique, and you require some specialist input. If you have any questions, you can drop in every day there and ask them for help. If you are not able to find the correct answer, of course, you can email me. But be warned, I won't be able to respond immediately because I am a little bit busy.